Let's consider question 3 now, where you've got 4 different bonds and you're asked to find the yield to maturity on each of these. So the first one is a zero coupon bond. So if you remember what the yield to maturity is, so we've got the price, and the yield to maturity is the interest rate that equates the price to the present value of the cash flows. So for bond A, a zero coupon bond, you can see that it just has it has no coupons, a par value of 1,000, so 1,000 divided by the yield to maturity. It's got a maturity of 5 years, and we observe that its current price is equal to 900. So effectively we're looking for the yield to maturity that equates this to this. So of course the way to solve this is to swap the 1,000 and the 900 around. So we get 1,000 over 900. That's equal to 1 plus the yield to maturity to the power of 5. So 1,000 divided by 900, so that's 1.1111. Now we need to get rid of this 5, so we'll raise both sides to the power of 1 over 5. Raise that to the power of 1 over 5. So the number on my calculator to the power of 0.2 gives me a number of 1.0213, and that's equal to 1 plus the yield to maturity, because obviously the 5 there raised to the power of 1 over 5, they cancel out, so we're left with the yield to maturity equal to obviously 2.13%. Hopefully you can see how straightforward that one there is. Let's look at bond B. Bond B is slightly more complex, but still achievable manually. So if you look at bond B, we've got a coupon paying bond with a par value of 1,000, coupons of 5%, a maturity of 2 years, and a price of 900. So the price is 900. In year 1 you get a coupon of 5%, so 5% of 1,000 is 50. 50 divided by 1 plus the yield to maturity. And then the next year you get your 1,050 divided by 1 plus the yield to maturity squared. So can we solve this? Well, because it's only 2 years to maturity, we can. And just to help, let's set x equal to 1 plus the yield to maturity. So we get 900 equals 500 over x plus 1,050, 50 over x, and then 1,050 over x squared. Now let's multiply through by x squared. So we get 900 x squared equals 50x plus 1,050. So I'm sure we can tidy this up. There must be a common factor in 50. So 900 divided by 50 you can see is 18. So that's 18x squared equals 50 divided by 50 is 1 equal to x plus 1,050 divided by 50 equals 21. And then if you reshape this, so it's 18x squared minus x minus 21, that's equal to 0. And of course that's the same as a quadratic equation. So we can solve this using x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So our b here is minus 1, so that's minus times a minus, so that's plus 1, plus or minus the square root of b squared, which is again the 1, minus 4 times 18 times by minus 21. So that's 4 times by 18 times by 21, which is 1 plus 1512, all divided by 2a, and 2a is equal to 36. So as you can see, let's sort that out. There's going to be 2 solutions, of course. So it's going to be 15, the square root of 15. So 1 plus the square root of 1513 divided by 36. So that's going to be 1.108. And another solution is going to be 1 minus the square root of 1513 divided by 36. So 1 minus the square root of 1513 equals, that's a negative number divided by 36, gives us minus 1.0527. So we want that x is equal to 1 plus the yield to maturity, so the yield to maturity is x minus 1. So of course, the solution that counts is this one here, so we take away 1 from that to get an answer of 0.108, so the answer is 10.8%. This solution here, of course, when we take 1 away from this, doesn't make sense. So there's our answer for the second bond, a yield to maturity of 10.8%. This only worked because it had 2 years until maturity. Let's skip bond C because it has some coupons, and I'll show you an Excel solution to that one. And for bond D, it's a coupon paying bond with a par value of 1,000, coupons of 5%, a maturity of 10 years, and a price of 1,000. So how can we solve this problem? Well, initially we could be confused, but then if we remember this relationship here between yield to maturity and price, such that when the bond is priced at par, the yield to maturity must equal the coupon. So since this bond is priced at par, the coupon is 5%, the yield to maturity must also be equal to 5%, else it wouldn't be priced at $1,000. So obviously that relationship there, remember that when yield is equal to coupon, the bond is priced at a par. When yield is greater than the coupon, it's at a discount, and when yield is less than the coupon, it's at a premium. So the answer to part D is 5%.